How's it going, guys? Lucilo here. I was looking through the assignments I had you guys do on DNA transcription, and it kind of seemed like people were a little bit confused still, and that maybe my explanation wasn't the best. And so I wanted to do a follow up in video format so that you guys could just have something to refer back to if you need it. And so, if you remember when we talked about DNA transcription, our DNA double helix, right, our ladder design, it actually unzips and opens up, and that's what you see in this picture right here. It opening up. And this is a little bit more of a cartoony representation of it, but you can also see here, right? Originally, we start with our two strands of DNA with our nucleotides pairing, right? A to T, T to A, C to G, G to C. And they pair all the way along until eventually it opens up. You can't really see it opening here, but that's why I added this image. It opens up like that, and a new strand of RNA starts forming paired to the DNA. So it'd be something like right here, right? It pairs along. Lost some brightness, sorry. Hopefully it still works. Right, and so we're building RNA. That's what we're doing. We're going to build an RNA transcript that matches our DNA transcript. And RNA follows all the same rules with this only difference. For DNA, A binds with T, G binds with C, and it's always true. When you're transferring to RNA, those same rules are still true. T and A bind, G and C bind. The difference being that when you're building the RNA strand, you never build RNA with T's. Right? If there's a T in the DNA, it becomes an A in the RNA. If there's an A in the DNA, it becomes a U in the RNA. So that's the big thing. RNA will never have a T in it. Okay, so if I have these two coding strands right here, AAT, GCG, TAG, these were taken straight from the homework, so it's the same problems. I'm going to turn this first one to DNA first. So this is like an intermediate step you can do to check your work. You don't have to do this part. But I'm going to go from DNA right here to the complementary DNA strand. So what would be the strand bound to this if it was DNA? Well, A would go with T. A would go with T. T is going to go with A, right? T and A always pair. G and C always pair. So figuring out the rest of this should be pretty easy. G goes with C. C goes with G. G goes with C. T goes with A. A goes with T. And G goes with C. So that's my complementary DNA strand to this one right here. This is what it would be. So my RNA strand should look exactly the same, but all the T's are going to be U's. All right. So this is kind of a roundabout way you could do it. You could always go DNA to DNA, just turning all A's into T's, all T's into A's, all G's into C's, and all C's into G's, and then flip all the T's to U's. That might be the easier way. When you get a little more natural at it, you can do it this way. So I'm still looking at this strand, right? Don't pay attention to this one right here. We're looking at the one in green. If I was turning it to RNA, I would do this. A becomes, normally it becomes T, but there's no T's in RNA, right? So this is going to be U. Another A is U. A T becomes an A. Okay, so that's the kind of part that people get mixed up. They start turning T's into U's, but it's not that the T's become U's, the A's become U's, because normally the A's become T's, but there's no T's in RNA, so they have to be U's. Right? So remember, still looking at this one in the green circle, G becomes C, C becomes G, G becomes C, T becomes what? A becomes U, and G becomes C. So you got to watch out for those A's, T's, and U's. G's and C's always the same. But if you compare these two, you should see they're exactly the same, but all the T's are just U's. Okay. So I'm going to do this next one now. All right, we'll start DNA to DNA. So we're looking over here now. DNA to DNA, G becomes C, C becomes G, C becomes G, A becomes T, T becomes A, C becomes G, G becomes C, T becomes A, T becomes A. All right, DNA to DNA, always pretty easy because we're just flipping the two letters. So remember, still looking up here, don't look right here. That's just an intermediate step. So still looking at this top one, what would the RNA form be? It should look identical to this, but all the T's should be used. So G is going to be C, C is going to be G, C is going to be G, A is going to be U, right? Normally T, but no T's in the RNA. A becomes U, T becomes A, C becomes G, G becomes C, T becomes A, and T becomes A. And so like I said, if it helps you to write out the DNA to DNA version first, which is a lot easier because it's just A's to T's, G's to C's, C's to G's, T's to A's, right? You just are flipping the two letters. If you want to do that first and then just change the T's into U's, you can do that. If you'd rather just go straight to RNA and skip that middle step and just always remember that T's are A's and A's become U's, when we're talking about RNA, that's okay too. And so you're going to use this today, take a little quiz. Make sure you guys be careful because I'm definitely going to have most that are this, but I'm definitely going to throw in at least one of these, all right, that you got to remember. When it's DNA to DNA, A, T, C, and G. When it's DNA to RNA, A, U, C, and G. All right.